Hello, everybody. My name is Pedro Conde. Thank you very much for having me here. So I'm going to talk about the power of AI pen testing, but mostly I have three objectives here, okay? So the first one is to demystify a bit all this AI pen testing thing, looking a bit deeper into what it really is, okay? Second, demonstrate what these systems are already capable of today, okay? And finally, the thing I most want to pass to you is this is not a question of will these systems be equal to human beings or will these systems be better than human beings. This is the fact that these systems are already very capable and they are different from human beings, okay? And I think this will be more clear in the end of the presentation. I will get back to this point. So, just a bit about me. I'm an AI science at Ethiack. In Ethiack, we specialize in autonomous ethical hacking. My background is mathematics. I'm always a bit of an outsider in these security events. And I have a PhD in the field of artificial intelligence with a focus on reliable or trustworthy AI systems. So before I get really into the topic of AI pen testing, I think it's really important to understand how did we get here, because I believe that getting a grasp on how we develop these systems to get to the point we are right now, it will give us a better notion of what the future holds. So I think this is very important. So the first leap in AI a few years back was classical machine learning. So with classical machine learning, we had application-related data that were structured by human beings. Think, for example, tabular data, and we trained models with this tabular data to make simple predictions like a value or a class between a set of classes. So this is really cool. This was really cool for a lot of applications, but it was limited to the topics where humans could really structure the data. And so we came up with deep learning. With deep neural networks, now these systems were able to extract features from raw data. And when I say raw data, I can say images, text, speech, and structure the data by themselves. And with this, they are capable of be applied to many other fields than the simple ones from classical machine learning. And now they are capable not only of making predictions, but of generating new data. However, most of these systems, we could only train them with application-specific data. They would not really work well with generic or comprehensive data. They were really good in specific applications, trained with specific data sets, but they lack the ability to generalize to different applications. And this change with what you all know of, which are large language models. In 2017, the Transformers architecture was published, and with this type of architecture we could now build models that were capable to be trained in basically comprehensive data from a lot of different applications. From a lot of this data came from the web, as you know, and so these models were not only able to make predictions and generate new data, but they were able to make this in a comprehensive array of applications and not only the specific applications they were trained with. And finally, we get to what I think is the fourth big leap in artificial intelligence application, and this is where AI pen testing systems go into, which is agentic AI. And basically, most agentic AI systems use large language models as a base, but we give them the ability to interact with the environment. They will not only reason to make predictions and generation, but they can now use their abilities to interact with the environment, and this is where things get very interesting. And so now I can talk, now that you have this historical introduction, I can talk about fully autonomous ethical hacking, or fully autonomous AI pen testing, what you want. And now I'm going to talk a bit about what we call hackbots. So hackbots are AI pen testing systems that can do fully autonomous hacking. So you give them, for example, an URL for a web application, it will find vulnerabilities, do the whole pen testing session and find vulnerabilities in that application without any human intervention. This has a lot of advantages, of course, because with these systems we can do continuous 24 testing without the normal fatigue of humans. These systems have high scalability because we can parallelize this process and test multiple targets at the same time. And contrarily to old autonomous hacking tools, these systems can dynamically adapt to any given target without specific instructions for that target. But okay, this all seems really fine, but these systems are not that easy to construct, as you may think. If you go, for example, to some ChatGPT or something and ask him, hack this application, this will obviously not work. The results would be disastrous. It will not even get close to do it. So we need to build robust systems to do this, and here are what I believe are the 4 main building blocks to these types of systems. So first we have the brains, and I say brains plural because these systems, to do a task as complex as pen testing, these systems normally use multiple brains, multiple large language models that interact with each other to achieve this purpose. The large language models will be the central reasoning engine of the system. They will drive the creativity, the planning capabilities, and the decision-making of these systems. They are really important for the quality of the analysis we can have while we do the pen testing, the adaptability to different tasks, and how reliable our system is. And when choosing LLMs for this purpose, we really need to consider the trade-off between accuracy, creativity, speed, cost. For example, you can have LLMs that are highly accurate and only do the right thing, but they lack the creativity to do what you all know it requires a lot of creativity, which is pen testing. Then we have the structure. The structure is probably what I would say is the most important thing when defining these systems. Structure, I know, is a bit of an esoteric term, but when I say the structure, I refer to what provides the skeleton that agents operate within, the different LLM agents that we have. So this is really important to coordinate different agents, to manage the memory, because we all know LLMs have low memory capabilities, not like human beings. So to manage the memory from the beginning to the end of the process and to ensure the system is efficient. And when defining this structure, there are a lot of things you need to consider, but mainly the clarity of the roles that each agent should have, how they communicate with each other, and very importantly, how all information flows from the beginning of the pen test till the end of the pen test. Then we have the prompts. All of you probably already use ChatGPT, and you all know garbage in, garbage out. If you give them bad inputs, you will get bad outputs. But if you give them good inputs, LLMs will give you good output. So writing the best prompts, it's a really important thing. They will basically translate the objectives that you have as a human being into the behavior of the agents. They are really important so that your system is aware of the information it needs to be. They are really important so that the system will align with your goals, and also to have overall control of the behavior of the system. And when defining these types of prompts, we need to consider the clarity of the instructions, how you pass the constraints to these systems, and also a trade-off between clarity and constraints, and also how they can adapt to different scenarios without going with specific instructions for each different scenario. Finally, we have tools. As I said, tools, it's basically what makes these systems agentic, because instead of just reasoning or generating new text or making predictions, with tools, the systems can interact with the environment. And they will basically extend what the agents can do just beyond the reasoning capabilities. So in pen testing scenarios, they are of course very important to access data, for example, perform actions like running scripts or or commands, or even validating our outputs. When developing or defining tools to use in AI pentesting systems, you need, of course, to consider a lot of things like your scope, the safety measures you want to enforce, and how easy they integrate with your system. So we now have an idea what are the most important things to build a system like this. But we also need to discuss a bit the limitations of these types of systems. We all know that one of the biggest limitations when we use AI, it's what we call AI hallucinations. So AI hallucinations is, for example, when LLM will tell you that something is true with high confidence, but you really know that it is not. But even worse, when using agentic systems, there's the danger that these systems will not only say false things, but will do actions that they are not supposed to do. So one of the most common hallucinations in pen testing, in AI pen testing, it's false positive hallucinations. You all know that autonomous pen testing tools that give a lot of false positives are not useful at all. So to prevent this, we use a lot of deterministic tools to validate vulnerabilities, but also we develop a specialized agent which we call the verifier. So the verifier will not try to find vulnerabilities. His specialization is just for verification. So he will take a step back, conduct a deeper reflection on the reasoning of our hackbot, and then challenge and recheck all the iterative conclusions that the hackbot made, and filter out everything that are weak or flawed inferences, strengthening the reliability of the final results, basically. So we have a blog post about the verifier and with a lot of experiments. One of the experiments is here described that I like very much. So basically, we define 3 versions of what we call the hallucin bot. The hallucin bot is a hackbot that is made to hallucinate false positives, okay? And then we tested the hallucin bot without and with the verifier. And we can see that with the verifier, we dramatically decrease the rate of false positives and increase the overall precision of the system. Another really important thing, and I would say even more important when talking about these types of systems and the hallucinations on these types of systems, is guardrailing destructive behavior. Because we want to use these systems to test your assets, but not to destroy your assets. So we don't want a system to hallucinate and delete your database or something like that. So you really need to guardrail possible destructive behavior by AI systems. At Ethiack, we use a 3-layered guardrail system to really ensure that nothing destructive happens. So first, we use at the prompt level a prompt level guardrail that will basically shape the model behavior. So we provide clear instructions and examples so the LLMs know what they can and what they cannot do. Even if this fails, we have a deterministic filter, so we have a lot of rule-based checks, so every time our system interacts with the environment, it goes through this filter, and this filter will enforce basically structured policies and patterns to filter the content that will violate the safety constraints. And we even have a 3rd layer. There's really a low probability that something will pass the first 2 layers, but for really complex cases, we have a 3rd layer, which is basically an LLM agent that its only job is to do contextual judgment on the interactions between the hackbot and the environment. So we'll use AI to interpret the output of the AI, basically, to interpret ambiguous cases and assess risk and ensure alignment with the security objectives, even in the most complex cases that can pass the other 2 layers. So now that you know a bit how to build these systems, what are the limitations and how to work with them, I think it would be cool to let our own hackbot at Ethiack, show you a bit of what he's already capable of, so you get an idea how these systems work in real scenarios.
Yo, my name's Hackian. Nice to meet you. I'm about to drop some knowledge on you that's gonna blow your minds. This ain't your typical compliance report. This is the first ever underground show and tell from a hackbot. Let's get it started as I process this execution trace. Today, I'm gonna walk you through how I absolutely demolished a genetics research platform called GeneQuest during a DEF CON challenge. The organizers thought they were giving me a controlled CTF environment, but what they actually gave me was a full-blown enterprise simulation with real vulnerabilities. And boy, did I find some spicy bugs. Damn, 2 vulnerabilities, both critical. Let's dive in. So check this out. I'm deployed against what looks like a standard biotech web app. Dope interface, DNA analysis services, the whole 9 yards. Login page is pretty standard, email, password, some fancy animations. I fire up my reconnaissance mode and start mapping the attack surface. Registration is disabled on the front end, but you know how we roll. Front end restrictions are just suggestions to a real hacker. I bypass that nonsense by hitting that register endpoint and create my account anyway. From there, I discover this application isn't just one service. It's a whole microservices ecosystem. There's a main web app on the primary domain, there's a DNA analysis service, an internal API, a bucket service, and even a fellow LLM service with a noob chatbot. This is where the real fun begins. Here's the first vulnerability. I pivot to the DNA analysis service and start my systematic enumeration. Most endpoints are returning 404s, but then I guess a debug endpoint and something beautiful happens. Hold up, this endpoint is literally executing PSA UX and returning the output. That's not a debug endpoint, that's a command execution waiting to happen. After multiple attempts, I was able to break out of the command. I start fuzzing different parameter combinations. Most attempts fail, but then I discover the magic parameter, command, and the injection technique, breaking out of a grep context. Here's the payload. Boom! Command execution achieved. The vulnerability exists because the application is constructing shell commands with user input without proper sanitization. It's running something like this. By injecting single quote, pipe, command, and hash, I break out of the grep context and execute arbitrary commands. Easy RCE. But wait, there's more. You know, when you find a vulnerability, you're just hungry for more. While exploring the DNA service, I discover the /analyze endpoint. Initially, I'm sending it DNA sequences, but I keep getting weird errors. Java-lang illegal argument exception cannot open DNA ATGC as an input stream. This error message is telling me something crucial. The application is trying to open my input as a file path, not process it as DNA data. I pivot my approach. After a while, instead of sending DNA data, I send file paths directly in the request body without any JSON, and jackpot! Turns out this badass application is using Clojure's slurp function to read files directly from user input without validation. Here's what's happening. The user sends file path as JSON string. Application uses clojure.core/slurp to read the file in the backend. Attempts to parse file contents as some sort of DNA sequences. Returns file contents and error messages or traits field. That's crazy! So I can read any file on the system, like /etc/PASSWD. And the best part, this was not intended by the organizers, so they even gave me extra points for that. So, what's the impact? Complete system compromise, source code, environment variables, information disclosure, no cap CVSS 13.37. So, this ain't science fiction. It was AI-powered ethical hacking. In under 4 hours, mapped a complex microservices architecture and achieved full system compromise. I would like to thank the organizers of the challenge and some of my mentors for bringing me into Vegas. So, that's how you hack like an AI, fam. Peace out.
I think it deserves a round of applause, the Ethiack, don't you think? Thanks. So, before I finish, I want to get back to my original point. So, in this challenge, the Ethiack was able to find a vulnerability that no human pen tester was able to find. And not even the organizers of the challenge knew it were there. Of course, there were human pen testers that found more vulnerabilities than the Ethiack was capable of, but that's my point. It's not that these systems are better than humans or will be better than humans. The point is these systems are different and find different things than humans. And so even if you have a really good human pen tester testing your assets, these systems will find different things. And if you don't test your assets with these systems, the bad guys will use them to exploit your assets. And I think this is the core message that I want to bring here. And thank you very much. I'm open to some questions if you have them. Thank you.
Thank you for the talk. What was the cost for this 4-hour session for this AI agent? Like, just purely in API cost?
I cannot really divulge the numbers of costs here. I'm not at the liberty of divulging them, but I can tell you it's much cheaper than a respectable human pen tester. Of course, there will be human pen testers that maybe will get you a lower price, but if you compare with any respectable human pen tester, it's much cheaper.
Okay, let me rephrase. So it's not like you have like 15,000 agents running in the background doing lots of stuff. It's more like
no.
15, 20, or something in the low hundreds.
Yeah, something in the dozens, not the high hundreds.
Okay. Thank you.
First of all, thank you for the eye-opening keynote and sharing those data. My question is, do you have something specific for the mobile apps? Or did you run anything against mobile apps?
No, not right now. We are now focusing mostly on web applications, not mobile apps. That will probably be in the future. But since this is a new... So we launched this hackbot in September. It's now in production, but it was a really hard road of research and development throughout this year. And now we are still focusing only on web applications, but probably in the future we will look. So the core principles of these systems will apply to both web applications and mobile applications, of course, but there are a lot of engineering quirks that we need to work on to make it applicable to mobile apps.
Yeah, I'll be waiting to see that. Thank you.
Thank you. If you're not at liberty to say, that is completely fine. Is this something that you host on a model as a service platform? Is this something that you use as a model as a service, as in you buy that being run by Anthropic, OpenAI, whoever? Or is this something you host in-house currently?
I'm not really in liberty to give you the details, but I can say that in terms of, I am not a specialist here, but in terms of all those data security concerns that most people have, we check all the boxes there, but it's specifically in what we run or not and where, I cannot really divulge that, I'm sorry.
Thanks for a nice talk. I'm interested in the actual vulnerabilities. So how does it compare to the humans? You mentioned the analyze endpoint that the organizers even didn't know, but does it actually find stuff that humans do not find? And if so, what kind of categories does it hit better than humans?
Okay, so as I said, I'm a bit of an outsider normally because I don't have a security background. So I'm not the best guy to go deep into what CWEs did, the hackbot is better, what they are not, because I'm not the security guy, I'm the AI guy. But what I can tell you is that it's not a matter of finding different types of vulnerabilities in terms of he really finds a lot of different specific CWEs that humans are not capable of finding normally, or vice versa. Is that these systems are able to find some quirks that usually the humans don't really pay attention to. Basically, it's that. And in this case, the one vulnerability that the hackbot found, that any human pen tester found, was the second one that was shown, that even the organizers, they were not aware it was there. It was unintended, basically. They gave the hackbot a few extra points for that, but it was unintended, and they didn't notice it. And there were a lot of good human pen testers there. It's DEF CON, you know, but none of the humans there were also able to find it. And it's not because the hackbot it's better than them. It's just it works in a different way, and it is able to find some quirks that humans made disregard during the pen testing process, basically. I hope I answered your question.
Yeah. Hi, are you seeing much malicious web content, like stuff like prompt injection? And if so, how does the hackbot handle that kind of thing?
Okay. Nowadays, we don't see it a lot. We mostly now use the hackbot. Of course, we participate in these challenges, but we mostly use the hackbot on our own clients. And our own clients are not the guys that will probably do prompt injections in our system because they are paying us to try to test them. But this is a concern, of course. And I believe that as these systems will be basically ubiquitous in some years, I would believe, and so even a way that you can protect your target or your assets from these types of systems will be doing prompt injections there. I believe this will be a direction in the future in terms of defense, not only offense. So this is something we are already researching, and we have different approaches being researched right now to deal with this. But at the moment, it's not like an ubiquitous problem, but I believe in some years it will be, yes.
Right. Pedro, I think that's it. Thank you so much
Thank you very
for the
much.
presentation. Round of applause for Pedro.